Hello students, I'm going to start a series of lecture on class 12 physics. So this is the Cbsc syllabus of class 12. So first chapter is electric charges and fields. That means let us consider here the charge Q. So it will produce electric field around it, spherically outward. So in this field, this is the electric field E. So in this field, if you put a test charge, suppose test charge is Q naught, so it will experience a force. If they are of same polarity, it will feel a repulsive force in this direction. So force. So we will try to find out what is the expression of electric field. So by the Coulomb's law, right? Coulomb's law between two charges. And then if there is more than one charge, suppose this is Q1, this is Q2, this is Q3. So what is the expression of electric field at this point P? Electric field is what? Or what is the expression of force due to this all this combination of Q1, Q2, Q3 charges? So this will be considered superposition principle. Now, if charges are not discrete, if it is continuously distributed in a current carrying wire, then we will take continuous charge distribution situation. Then we will calculate what is the expression of electric field, and then Gauss law or Gauss theorem, electric flux. Then we will calculate what is in chapter 2. We'll calculate what is the expression of electric potential is equal to what, and capacitance, expression of capacitance, dielectrics. Then chapter number 3, current electricity. Suppose now charge starts moving. This charge is moving. If it is positively charged, then if charge is moving in this direction, then current will flow in this direction. Now, if it is electron or negatively charged particle, then current will flow in the opposite direction. So this will flow. Charges will start moving. So because of this movement, there will be drift velocity, there will be mobility, and they will study Ohm's law, VI characteristics, Kirchhoff's rule, Wheatstone bridge, then resistivity, conductivity. These things will come. Then chapter number 4, moving charges and magnetism. As this charge starts moving, because of that, there will be current will flow. So it will produce magnetic field around it. So the most important concept is Biot-Savart's law, and then Ampere's law. So it says if a current carrying wire carrying a current in this direction, then there will be magnetic field around it. So at this point, magnetic field will be inward, and at this point, magnetic will be outward. For different situations, current carrying loop, magnetic dipoles, magnetic dipole moments. And then chapter number 5, magnetism and magnetic matters, like bar magnet, different magnetic materials like paramagnetic material, diamagnetic, ferromagnetic materials, and their examples. Then chapter number 6 is electromagnetic induction. Electromagnetic induction, important topic is Faraday's law, induced EMF, induced current, Lenz's law, self-induction, mutual induction. In chapter number 7 is alternating current. Alternating current, peak value, RMS value, different circuits like LCR circuit. Suppose this is the input, capacitor C, inductance L, and resistance R. They are connected in series. So V equal to V naught sin omega t. What current? What is the expression of current? Does current leads or lags behind the voltage or not? Then AC generator, transformers. Then chapter number 8 is electromagnetic waves. We'll study displacement current, electromagnetic waves, and their characteristics, different spectra, radio wave, microwave, infrared, visible, ultraviolet, X-rays, gamma rays. Then chapter number 9, mainly topic is optics. So there is ray optics, and wave optics. In ray optics, you will study also optical instruments like microscope and telescopes. In ray optics, we will study thin lens formula, mirror formula, lens maker formula, extremely important. This is lens maker formula, then prism. And wave optics, we will study Huygens principle, then interference, double slit experiment, and its fringe width when we will study diffraction due to single slit experiment, single slit. Then chapter number 11, dual nature of radiation. Dual nature of radiation, that means radiation and matter, right? So we'll study photoelectric effect, which is particle nature, which is particle nature of light, and this Young's slit, double slit experiment, which is wave nature. Wave nature. So that's why this topic is dual nature. So we'll study photoelectric effect, Einstein's photoelectric equation. Energy E is equal to work function W plus EK. EK is kinetic energy. Sometimes we will use at kinetic energy, sometimes we will use as EV naught, stopping potential. Then matter wave. Matter wave. And de Broglie relation, lambda equal to h by p. P is the momentum, that means this is particle nature. Particle nature, and lambda is wavelength, this is wave nature. Chapter number 12, atoms or atomic physics. So Rutherford did gold foil experiment, Rutherford's atomic model. So he took a gold foil and he bombarded it with alpha particle called helium-24. He observed that 99% of those alpha particles simply simply passes, but 1% of those alpha particle comes back. So from this experimental evidence, he came to the conclusion here is huge mass present at the center, so which is called nucleus. Which is called nucleus. And then Bohr's model of hydrogen atom, the radius of the hydrogen atom, velocity, energy. The Bohr's model, energy, expression of energy, En is equal to minus 13.6 by n squared, it is in electron volts. And the radius, he gave us the expression of radius, Rn is equal to what? What is the velocity of the electron in different orbits? In chapter number 13 is nuclei, composition and size of the nucleus, nuclear force. Nuclear force is attractive in nature. Attractive in nature. So even if inside the nucleus there is huge number of protons and also huge number of neutrons present. This is neutron. This is proton. So proton, they repel each other. Even if they are repelling, still there is huge force which intacts, which is responsible to bind those nuclei inside the nucleus. That's why we will study this binding energy or binding energy per nucleon and the variation of mass and the binding energy per nucleon and its variation with the mass number. We will study this curve. It is extremely important. We'll study this curve. And this is the most stable nuclei in this universe, which is ferrous, iron, ferrous 56. This binding energy per nucleon versus the mass number. And we will study nuclear fission, nuclear fusion. Then chapter number 14 is semiconductor electronics. We will study different materials like semiconductors, insulators, and semiconductor. There is intrinsic semiconductor, extrinsic semiconductors, p-type, n-type, and then p-n junction. We will study this p-n junction diode and its IV characteristics, forward bias, and then reverse bias. This IV characteristics. So this is ISC syllabus. Everything is same. Little bit enlarged version is there. We will quickly go through it. So here also we will study in electrostatics. We will study electric charges and fields. We will go through those Gauss theorem, electric flux, Coulomb's law, superposition principle, continuous charge distribution. Then potential, expression of potential. What is the expression of potential? What is the expression of potential energy? What is the expression of capacitance? Then electric current. As charge will start moving, current will flow. So charges are moving. That means there will be drift velocity, mobility, drift velocity, Ohm's law, VI characteristics, electrical resistivity, conductivity, temperature dependence of resistance. Then chapter number 3, magnetic field of current and magnetism. As current flows, magnetic field will be there around it. Current is flowing in this direction, so there will be magnetic field around it. Right. So we'll study here Biot-Savart's law. We'll study Ampere's circular law. Then magnetism and matters, magnetic matters, like diamagnetic material, paramagnetic material, ferromagnetic material, or substances. Next chapter is electromagnetic induction, Faraday's law, Lenge's law, eddy current, self-induction, mutual inductance. Then transformer. Then we will study electromagnetic waves, and their characteristics. Next chapter, chapter number 6 is optics, ray optics, and optical instruments, microscopes, telescope, ray optics. You will study thin lens formula, lens maker formula, magnification, power of the lens. Right. Then there will be wave optics. We'll study Huygens principle. We'll study Young's double slit experiment. We'll study Fraunhofer diffraction due to single slit. Then dual nature of radiation and matter. We'll study this Einstein's photoelectric equation, matter wave, de Broglie relation. Next chapter is atoms or atomic physics. We'll study same Rutherford's experiment, atomic model, Bohr's atomic model, different hydrogen spectra for different energy levels. We'll study nuclear physics, the size of the nucleus, composition, mass defect, binding energy per nucleon, nuclear fusion, fission. We will study electronic devices, semiconductor diode, IV characteristics. We will study here Zener diode, P-type, N-type, PN junction, intrinsic semiconductor, extrinsic semiconductor.